projects. In this video, we are going to discuss about the project which is object detection using YoloV7. So let's understand what is the project about. So what is object detection? Object detection is like teaching a computer to recognize and locate objects in pictures or videos. So imagine showing a computer a photo of a busy street and asking to find and label all the cars, pedestrians and traffic signs in the scene. So this object detection algorithms, they are designed to do just that. They analyze the image, figure out what objects are in it, and then draw bounding boxes around each one, saying what it is like a car or a person. So this is super useful for things like security cameras, self-driving cars, and robots because they need to understand what is around them in order to make decisions and take action. So traditional object detection methods such as HOG or Viola Jones, they work better, but they're not great at handling complex situations and they can sometimes make mistakes. So to overcome all these limitations, we are proposing YOLO V7. YOLO V7. So this project is all about making object detection better using more advanced model called YOLO V7. So we use this YOLO V7 for detecting objects in images or videos more accurately and faster, which can be really useful for things like surveillance cameras or self-driving cars. So what is this YOLO? YOLO, it refers to you only look once, and it is fast object detection algorithm that processes entire images in just one go. And it predicts bounding boxes and object class simultaneously. And this YOLO V7 is an enhanced version of YOLO, which integrates advanced deep learning techniques like feature pyramid networks and anchor based object detection. And it also utilizes efficient backbones like CSPD Darknet 53 to improve speed and accuracy. So these advancements make YOLO V7 ideal for real time object detection tasks. So moving on, we have used YOLO V7 to detect the objects. As a front end, we have integrated Flask for building the web application to deploy our project. So what is this Flask? Flask is like a web framework, that is lightweight web framework for creating websites using Python. And we use Flask in this project to make a website where people can interact with our object detection system. So with this Flask, we can set up features like sign up and sign in using a simple database called SQLite 3. Users can also upload images on the website for analysis. Flask helps to manage all these interactions by directing them to the right parts of our project, that is backend, where the images are processed and predictions are made. So in this way, users can easily use the project through web browser. Furthermore, to implement this project, we need software and hardware requirements. So coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now let's execute the project. So to execute it, first we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let's understand each of them, how will they be used in the project. Let's see the data set. So we have data set in YOLO V7. So I'm opening YOLO V7 folder. There are two subfolders, one is train and the other one is valid. In train, we have two more subfolders, one is images and the other one is labels. In images, we have images. So we'll be using all of these images to train the YOLO V7 algorithm to detect objects within the images. So now get back, coming to the labels folder. Here we have files containing annotations or labels for objects in corresponding images. So each label file, it corresponds to an image file in the image folder. For example, this file, it corresponds to this image and this file corresponds to this image, and it provides details about object locations and classes within this image. So for all the 13,690 images, we have 13,690 label files. So here we can observe there are 13,690 label files, which provides the object locations and classes within all the images which are corresponding to them. So let's open a file from all these. So for example, I'll show you the first file. File has been opened. So here each line represents a detected object. So here we can observe that there are 4 objects detected as they are 4 lines in the file. Each line it specifies, each line it specifies one object class index followed by its bounding box coordinates, which are normalized to image dimensions. So here 0 represents one type of object, 14 represents some other type of object. Similarly, we will have multiple classes, that is multiple objects. So moving on to the bounding box coordinates. So these are the bounding box coordinates. This is the x limit, this is the y limit, this is the width, and this is the height of 0 object, that is 0 class object. So similarly, we have for the other objects also. In same way, we will be having in all the label files. So now close this, get back. In validation folder also we have images and labels. So here we have images of 3422. But in train folder we had 13,000 change of images. So for all these 3000 images we have same 3422 label files. Same as train folder. So we'll be using this train folder to train the YoloV7 algorithm to detect the objects, and this validation folder to evaluate this YoloV7 algorithm, that is how will this YoloV7 will perform on this unseen data. So now get back. Here in the sample folder we have images. So we'll be using all of these images as the test cases in the front end to detect objects. Get back. Moving on to the static folder, this folder contains files related to project styling and the interactivity. They include CSS, JavaScript, and Bootstrap files. The next file we have is templates folder. So here lies all the HTML pages utilized in the project. They are index.html, about.html, and each HTML file represents a different page of the website which provides the structure and the layout for displaying content to the users. And here we have app.py file. So this Python file, it encompasses front-end logic of the project, and it handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. This is the model file which contain the algorithm information, and this will be loaded into project code during runtime. And this is notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells. And the last file we have is sign up file. This file is a database file which is used to store the user information. So we understood all the files. Let's execute it. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and now click on enter. So here we can observe that current directory is changed to the code folder's path. Now compile app.py file by giving the command python space app.py and now click on enter. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash framework will host the application locally at the default address, which is the localhost and the port. So this is the localhost and this 5001 is the port number. So now we need to copy this link provided by the Flash framework and paste it in any web browser. I've copied the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here. Now click on enter. So this is the web page of the project, which is developed using Flash framework. And this is displayed in the browser. Click on sign up first. Enter all the registration details if we are registering newly. I already registered and I have an account already, so I'll directly sign in. So click on sign in. Provide credentials, which are username and the password. Now click on login. We have logged in successfully and we are redirected to detection page. So here we can see a choose file button. We need to click on that for uploading the images, for detecting objects in the images. So click on choose file. So these are the images using which we'll be detecting objects within the images. So first let's upload the first image. Click on open. Here we can observe that image is loaded. Now click on upload. Here we got the detection. A person is identified, that is detected, and a purple color bounding box is drawn around the person and labeled as person, and given the detection score, that is 0.85. Detection score is nothing but it is confidence level that how accurate the detection is. So it is accurate up to 0.85%, that is 85%. Let's upload some more images, get back. Click on choose file again. We'll be uploading the second image. So here we got the detection. There are multiple objects detected from the image. Here we can observe that aeroplane is detected, two aeroplanes are detected, one car is detected, and two persons are detected. Car is drawn with the pink color bounding box. Persons are drawn by the purple color bounding box, and aeroplane is drawn with the blue color bounding box. Let's upload some more images, get back. Click on choose file. So now we will be uploading this image. Image is loaded, now upload it. Here we can observe that there are two TV monitors detected and bounding box is drawn around them with their detection scores and labeled as TV monitor. Let's upload some more, get back. Click on choose file. So now we will upload this image. Click on open and now upload it. Here we can observe that there are many objects detected. Bus has been detected, car is detected, aeroplane is detected, and persons are detected. That is, people are detected. Get back. We'll upload one more image. So now we will upload this image. Here we can observe that there are three detections, that is three kinds of detection. One is bus, multiple persons, that is multiple people, and one bicycle. Let's upload some more, get back. Click on choose file. So we'll be uploading this image. Now upload it. Here we can observe that there are two objects detected, that is two kinds of object detected, but three objects are detected. So two kinds of objects are motorbike and potted plant, and three objects are two motorbikes and one potted plant. So wherever there is object detected, bounding box is drawn around them. So here we can observe that red color bounding box is drawn around motorbike and brown color bounding box is drawn around potted plant. Let's upload some more, get back. Click on choose file. So now we will be uploading this image. Image is loaded, now upload it. Here we got the detection. So there is one detection, that is two types of cows are detected. So here we can observe there are two cows detected with 0.86 probability score. Let's upload some more, get back. Click on choose file. Now we'll be uploading this image. Upload it. Here we can observe that object sofa is detected and a brown color bounding box is drawn around it. Let's upload one more. Click on choose file. So now we will be uploading this image. So here we can see boat is detected. Get back. We'll try using some more test cases. So let's upload this image and now upload it. Here we can observe that there are two kinds of objects detected. One is dining table and the other one is chair. So in dining table, two dining tables are detected and two chairs are detected. Get back. Click on choose file. Let us upload this image. Click on upload. Here we can observe one bird is detected with the 0.94 detection score. Get back. Click on choose file. So now we will be uploading this image. Now click on upload. So here we can observe that there are multiple kinds of object detected. One is train and the other one is car. There are 5 cars detected with the pink color bounding box, 1 bus detected with the brown color bounding box, and persons are detected. Now get back. As of now, we did detection using the sample folder in which we have our own test cases. Now let us try using images from the Google. So let's open the new tab, click on plus symbol. So we will search for a person riding a bicycle. We'll be saving this image. Get back to the web application, click on choose file. As we have saved this image, click on open and now click on upload. Here we can observe that there are 2 objects detected. One is bicycle, which is drawn by orange color bounding box with 0.63 detection score. And the other one is person with purple color bounding box with 0.90 detection score. Similarly, we'll upload some more images, get back. We'll search for some more images. Now we will search for bird images. So I'm saving this image. Get back to the application, click on choose file. So I'm uploading it. So this is the uploaded image, and here we got the correct detection as bird is detected and a green color bounding box is drawn around the bird with 0.92 detection score. Let us upload some more images using Google Images. Get back to the new tab. So we'll search for person with boat. Let's save this image. This is not appropriate. We'll search for some more images. We'll save this image. Get back to the application, click on choose file. We have saved this image, click on open and now click on upload. Here we can observe that a person is detected and a purple color bounding box is drawn around the person. So let's try using one more image. We will search for vehicles on roads. So we'll save this image. Get back to the application, click on choose file. So we'll be uploading this image as we have saved the same image. Click on upload. Here we got the detection, and here we can observe that there are multiple cars detected and a pink color bounding box is drawn around all the cars. In same way, just by uploading images to the system, that is application, it will detect objects within the images. So now click on sign out. The project has successfully built using YoloV7 algorithm in improving object detection tasks by integrating advanced deep learning techniques. YoloV7 achieves notable enhancements in speed and accuracy compared to traditional methods.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.